Hey you guys, welcome back to the channel Physics Surgery, and here we are in JEE Advanced Solutions series, which I call as Alpha and Omega of your preparation. That is the first and last step of your preparation for JEE Advanced. And this video is a bit of different from the previously done videos on JEE Advanced Solutions, wherein I used to take the question as it is from the previous year's question papers and solve it through the conceptual and elaborate explanation and finish off with the practice problem. So what I did here is I brought a very famous 2016 JE passage on Coriolis force and centrifugal force. You could see the diagram of the actual question in the middle of the thumbnail. But what we are going to do is we'll try to modify the question, try to make it a bit more twisted into a new passage, but at the same time not lose the essence of the original question. So the whole idea is to understand the concept of the centrifugal and Coriolis forces in a deeper manner so that we are ready for any future modifications that IIT JEE may itself do in the process of preparing a question. So this is going to contain the concept, a recall towards some of the previous nicely done videos on this channel, the solution to the problem passage that I'm going to present, and also as usual round it off with nice little practice problems at the end. Okay, so let's go forward in looking at what is the problem statement. Okay, so this is going to be a passage similar to the JEE Advanced 2016. In actuality, what we did here is we took the entire passage as it is the same. So in the actual question, as you saw in the thumbnail, the groove of the table was on the diameter. Instead, we moved it to a chord so that we understand the Coriolis force and the centrifugal force in full glory. Okay, so as the passage suggests, I would request you to pause the video and read it on your own if you're a new student who is doing this question for the first time. I'll just give you a gist of it instead of reading and wasting the time. Okay, so in the rotational frame, compared to the inertial force, there will be two pseudo force components that you have to add. We are assuming the omega is a constant. So if alpha were also there, you would have got a third force called Ural force, which you are not looking at in this problem. So the first force, which is given by 2m into v relative or v rotational frame cross omega, that is the Coriolis force component. And the second one is the famous centrifugal force component, which is always away from the observer. In this problem, on the chord, which is of length 2L, okay, or 4L length, from middle it is 2L. In at a point B, a particle is left, and we are supposed to see the motion of the particle and answer two questions. So we'll just go forward for the questions here. So that these are the two questions similar to the ones that were asked in the JEE Advanced 2016 paper. So in this diagram, as a function of time, you need to calculate what is the distance of the particle from the point O, taking axis in this manner. Okay, x and y axis are the horizontal plane and the z axis is perpendicular or in the direction of angular velocity. Similar to the second question, right, you have the net reaction force by the disk on the particle in the vector form. So you need to solve for the normal reaction components in J and K direction. So these are the four options. Okay, so we'll try to see how we can solve that. So before we move on to digest the concept and the solution, one humble request as always to keep the channel alive. I would request you to merely give a like to the video, especially if you have gained something out of this video. It would be a free one for you, but it will be invaluable for the channel. And 750 likes, once it reaches, I'll upload the immediate next video. Or else, if the 750 target is not reached, I'll upload the video in the next 14 days. Okay, so whichever is the first. So thanks for all the unconditional support you have been showing, especially in my downtime when I was ill, right? So you were all the way supporting the channel. So keep sharing and keep liking the videos in this channel so as to help us. Okay, right. So let me recall very quickly the concepts that are already taught in this channel about the centrifugal force. Can you see at the left of your screen? In a rotating frame, if an observer is fixed to the rotating frame and he or she tries to observe a body and tries to draw its free body diagram, and in order to apply Newton's laws, remember, in rotating frames you cannot actually apply Newton's law until unless you identify pseudo forces. So among the pseudo force components, one important component of pseudo force is the centrifugal force. And what is the thumb rule? After, remember, 2 videos we proved it, that the centrifugal force by definition is always away from the observer and is calculated as mr omega square, where r is the distance between the observer to the object that he is observing. Okay, so this is something that was already taught. I'll give you the links of those videos in which we proved this. If you are new to this channel, just wait. In the next slide, I'll provide the links. And this is a gist on the right hand side for the Coriolis force component of the pseudo force. If in a rotating frame, you are observing a block to be having a relative velocity called V relative. In the passage, he writes it as VROT, V rotational. I am writing it as V relative from the rotating frame. Then the formula of 2m into V relative cross omega gives rise to the value of the Coriolis force component. Okay, so these are the two things that we'll take and move forward. So those who are new, I would suggest there are subtopic playlists of rotational mechanics, subtopics, because I divided rotational mechanics into further 4 parts. All those 4 playlists are in the description below. You should check them out in order of their upload. Okay, so once the video is done, you can go there. 2 of the old videos which are directly connected to this particular concept that I was discussing in the previous slide are the landmark videos on this particular channel. The 100th video, which dealt with the complete proof of all the components of the pseudo forces in rotating frame, Coriolis, centrifugal and Euler forces, etc. All those things. It was very well received video on this channel. So 100th, and once the 200th video, I did a sequel for that and trying to understand the misconception about the centrifugal force by pointing out a mistake from H.C. Verma's sir's book of volume 1, okay, Concepts of Physics. So please do check the links of these videos are in the description below. All right, I'll put the 200 videos link in the I button above. Okay, so right, so once you've done those, the concepts become very clear and you will be able to apply the Coriolis force easily. So for those who don't want to go to those videos and want a quick revision, so here's a slide to quickly revise a visualization of the Coriolis force vector. So there is a very famous example to illustrate this. So you could see on the left side of your screen, there is a platform which is rotating and 2 observers are on the opposite ends of the platform. And the job is to throw a ball from one observer to another. Okay, right. So one person should throw the ball towards the other person. And if the platform was non-rotating, the ball would have just reached that fellow. So this fellow now does the same job of throwing the ball towards this guy, but with the platform rotating clockwise, as you can see. So what actually happens is that from an inertial frame where Newton's laws are applicable, the actual path will still be the same, assuming the platform doesn't have any friction or anything. This red line and this red line should be the actual path. The ball seems to miss this person because that person went away from that red line. So if you ask this rotating frame observer what happened, he would say he's at rest and ball missed him and went to the left of him, as you could see. So to explain this leftward mysterious, or you could say illusionary movement as seen by this guy, remember, in actuality, it goes along a straight line. Newton's first law, a body moves in a straight line until unless it is acted upon by a force, which is true. But this guy, who is a rotating frame observer, he thinks that he has missed the ball. Okay, right. So reverse, actually, he thinks the ball has missed him. So the ball, he tries to explain by using a curvilinear path. To explain that curvilinear path, a false force, a force that doesn't actually exist, it's an unreal force called Coriolis force is assumed. Okay, so like I said in the previous video, that force value or the formula was derived. Okay, so in this diagram, you see omega is clockwise, so something like this. So if you use right hand thumb rule, the direction of omega vector along right thumb would be this way. V relate to this red color vector I have drawn here. So the direction of Coriolis force is V relative cross omega. Use your right hand, and the direction of the V relative cross omega would be this blue color one. And because of that, this blue color relative path would be seen. Okay, so that's the idea. So just to visualize this, I will show you a simple small video. It's done by one of the famous colleges called MIT. Okay, so now what we are going to do here is we have a observer rotating on a frame that I showed, and you are the opposite person. Okay, so you are the camera, and that camera is attached to the rotating frame. So we'll ask this person to throw the ball towards you. Okay, so ball should go in a straight line with respect to ground observer, but you go away from the ball and you will miss the ball. Okay, so what you're going to see is what a rotating frame sees, and you would see that mysterious curved path for the ball, which actually doesn't happen from the ground frame. Okay, so you see the ball will go in the direction of V cross omega, suggesting the presence of Coriolis force from rotating frame. Okay, so you're observing it from the rotating frame. Let me play it through. It's going straight, but you could see ball is going towards your left. Imagine ball was coming towards you and you missed it. And if you are the rotating observer or rotating frame observer, you will try to explain this using the Coriolis force. Okay, same thing if you see it from the top view, it will become even more clearer. Let's see. Okay, so you were this guy and the ball was thrown straight actually, but you went away and ball seems to have taken a curved path. We'll try to show the path also along with a dotted line. So you see, ball seems to have curved. There's no real force on it. It is just an illusion. Remember, the camera is attached to the rotating frame. So from that frame, this 2m into V cross omega is seen as the reason for this curvilinear illusion. Okay, right. With this visualization established, for those who have not seen the previous two videos, I think understanding this formula would become easier. Okay, so let's move forward and apply it in our problem. Okay, a lot of things on the screen. So let me try to explain step by step. Listen to my voice carefully. Look at where I'm pointing. I think you'll be fine instead of reading it on your own. Okay, so as I said, this modified problem, we put a cord at a distance d away from the center. Okay, and we are taking a top view like in the previous camera. The disk is rotating with an angular velocity omega. The block was left at a distance L from the center of the slot. The total length here is 2L. Then block will move away from the slot. Okay, right. And this distance X is measured in this fashion. Okay, right. You can take y-axis this way or that way. It depends on what the question paper setter has given. Z is out of the screen. Okay, out of the board. So you could say the kinematics equation of motion in rotating frame. Remember, in the rotating frame, this X direction, d square x by dt square should be given by omega square x. How did I achieve this? Now look at the free body diagram of this block coming here. Okay, right. There are the two pseudo force components. One is the centrifugal force, which is away from the observer who is attached here. Okay, so I put the rotating frame guy somewhere here. So he's observing it this direction, mr omega square, FCN is centrifugal, this angle theta and the distance r. So that's why r figures in this. And F Coriolis would be related to the V cross omega cross product, which in this problem comes out to be in this direction. Okay, so 2m into V omega. V and omega in this problem are perpendicular, so I took the product itself. Now, if I draw the actual free body diagram with real forces, remember these red colored ones are the real forces. I take the components of mr omega square this way and that way, sine theta and cos theta, and you could see r sine theta is x, so that's why I could put mx omega square here, and md omega square would be in this direction. Remember, this distance or this distance is the d. And out of the board, there is another normal reaction from the floor of the slot, and into the board there is an mg. Remember, we are looking at the top view. So as I said, the away going tendency in the rotating frame can be explained by this component of pseudo force, okay, mx omega square. So that's what I did. That x omega square becomes the relative acceleration along the slot. So you can write d square x by dt square as v dv by dx, where v and this v are relative velocities. Remember, these are from rotating frame. So I rearrange, I integrate, I get a constant called C1. The value of C1 can be found from the initial condition where he said at x equal to L, the body was left on its own. So I substitute back, I end up getting a velocity versus x relation. I have to get x versus t, right? So I'll write v as dx by dt, rearrange. I need to know the standard integration of this, which is the value of cosine h inverse x by L. Okay, so cosine h inverse. It's instead of calling it cosine, you can call it as cos hyperbolic function. And rearranging, you end up getting this by again substituting the initial condition that at t equal to 0, the value of position is x equal to L. Okay, and this cosine hyperbolic function can also be written in terms of exponential format in this manner. Okay, so this needs to be known. This red colored conversion, the standard integrations are expected to be known for a math student preparing for IIT JEE. Okay, so this x equal to L by 2 into this function comes out, and I differentiate this further with respect to time to get v as a function of time. This v is required to write the Coriolis force in function of time. Now Newton's laws tells you that outward n prime should be balanced by mg. So that's what I've written here. And this n, which is perpendicular to the slot, should be balanced by a combination of a component of pseudo force, which is the centrifugal md omega square, and this 2mv omega. So that's what I've written here. And attaching the y and x unit vectors to it, the total reaction vector that he asked in the second question would be the vector summation of these two. These two are not directly addable because they're at 90 degrees to each other. So I attach a k component and the j component here. So with this, we will try to go and mark the answer and then move on to the practice problems. Okay, so the answer, the best answer for this would be this one, A. And for the second one, with a minus here, can you see that minus was missing in the original print of the paper? I added it. You can check it out with the x and y components here. Okay, so answer should be C, right? I hope you're ready for the practice problems now. Okay, right, before we move on to the practice problems, these are the ways to connect with me. The top three are for the aspirants. Okay, a Discord server where students discuss doubts, along with the Telegram group where serious students actually discuss doubts of different JEE level questions. Website is a place where you find all the videos of this particular channel in a categorized manner, and in future also we'll be having lectures put up there. And bottom three are for general people who want to follow me on the social media. Okay, so and regarding the website, okay, I have already made a tutorial video on how to use the website to maximum effect from the students. Okay, so what are the problem sets and what are the lectures, etc. So please do watch that video. The video of that is in the description below, link, and also on the I button above. You can check it out. And this is the practice problem number 1. Okay, so yeah, some names have been given just to interest you, but the concept is even more interesting here. So there's a girl sitting at the end of the turntable, and there is a boy who is standing outside at the same horizontal level. And this problem tests your understanding of calculating the relative velocity from rotating frames. Okay, so I've done already 2 or 3 videos on achieving this. So this original problem, try it out and comment your response below in the comment section along with the timestamp. And if you struggle, I'll come up with a solution of this in the originals video. Timestamp is important. Otherwise, as the video gets old, if you just post the doubt, I'll not be able to answer. And practice problem number 2 is your understanding of centrifugal force. Okay, so this, we're going step by step. First relative velocities, then the centrifugal force. Okay, so I have seen a lot of students actually get this one wrong, especially in the 200th video. I pointed out the mistake from the H.C. Verma's book, right? So this is along that particular direction. So try it out. I'll answer this in the physics surgery quickies. You can comment your response below with the timestamp. Okay. Practice problem 3 is actually extension of the present ongoing video. Again, we copy paste the passage that was given in 2016 and we convert it into a new situation to estimate the centrifugal and Coriolis force. So I request you to read this passage with these two as the figures that are given. Okay, so I'll show the next slide for the questions. Okay, so these are the two questions. This is the problem statement for these two figures. These are the two questions. So this appeared in one of the All India test series at our center for the weekend examinations for the students that I teach. So I thought you would gain something from solving this problem. Comment your response for these two questions below the timestamp, and I'll answer this in the AITS test series. Okay, right. And as I said at the start itself, so those who are new, please do check out the subtopic playlist. 4 of them are there. in the rotational mechanics, one of the important topics for your JEE Advanced. The links of those are in the description below. Watch each and every video. Try to watch it in 1.25x speed if you are running out of time and you're preparing for an exam coming fast. Then that should be the best way to prepare for your exam. Okay, so regarding the Discord server, there is separate rotation channel in our Discord server. It may not be active right now with students going for exams, but already the present segregated questions in that channel, if you scroll up, there is a whole gold mine of great questions and great answers that were posted by serious subscribers in that particular channel of Discord server. What is Discord server? How is it useful? What is it to be done from the beginner's side? I have prepared a video tutorial on using it. Please, a link of that video is shared in the description below or the I button above. You check it out, and please do hit the notification bell icon of this particular channel so that you receive, keep receiving the questions that I post in the community tab. So notifications will be useful, especially if you're serious and you put the phone or computer away and you want to only switch them on when you have a serious and a good video coming up. Okay, so that should also conclude the video with important series that are there apart from the JEE Advanced Solutions, which are famous on this channel. There are many series, only 4 of them are written here. All the links of the most important series are in the playlist form, and they're in the description below. You check them out. As I said, liking the videos of this channel, I think helps not only me, but also students when I keep coming up with good videos. If the likes go down, the response to the channel goes down, then the motivation also from my side will not be at a higher levels to actually share the content with you people. So keep the motivation high, keep the love coming in my direction. And I promise you the quality that this channel is reputed for will keep going on and on. Okay, thanks a lot for staying this long, and see you in the next video.